Hi, I'm Anson Chen and I'm going to talk to you about the physics of archery. Before I get started, I'm going to give you a little information about the origins of the bow and how they work. The bow and arrow goes all the way back to prehistoric times. Bow and arrow points have been found in South Africa that date all the way back to 58,000 BC. Throughout time, the bow and arrow has been a versatile weapon for hunting and fighting. Today there are three different kinds of bows: the long bow, the recurve bow, and the compound bow. Each bow has its pros and cons, but today I'm going to be talking about the longbow. The English longbow was primarily used for fighting during the Middle Ages. It is considered to be a difficult bow to master since the draw weight usually exceeds 50 kilograms or 110 pounds. The draw weight is caused by the tension of the bow when the string is pulled. When the string snaps back from the tension of the bow, all the potential energy will convert to kinetic energy that will go from the bow to the string to the arrow, sending the arrow forward. The tension of the bow will determine the speed and the strength of the arrow. Of course, if you want to hit the bullseye, you also need to account for how far you are from the target and gravity. However, there's more at play when you want to hit the bullseye than just speed and gravity. The archer's paradox is an interesting phenomenon involving the arrow itself. When an arrow is shot, the arrow isn't completely straight. It oscillates. The arrow isn't a completely rigid structure. If it were, when an arrow is shot, the arrow would always stray towards one direction. This is due to the arrow not being able to get around the bow. To get around that, arrows are made to bend. When the arrow is shot, instead of straying towards one direction, the arrow builds up pressure by bending. Once enough pressure is built up, the arrow snaps back in one direction, curving around the bow. The constant building up and snapping back is what causes the arrow to be stable and fly as straight as possible. Archers use this paradox to help with their accuracy as well. 9 times out of 10, the point where the oscillation intersects is where the arrow will hit.